Hello, my name is Diana Arzamasova, and today I am glad to introduce you to one of the strategic academic units of MIFI, Institute for Nanoengineering in Electronics, Spintronics, and Photonics. The most popular law that describes the development of modern electronics is the Moore's law. The number of transistors on a microchip doubles every 24 months. The graph shows a decrease in design standards, which is necessary for increase in the number of components. Transistor is a semiconductor device used to amplify or switch electronic signals. Principle of operation. A voltage to one pair of transistors terminal controls the current through another pair of terminals. Because output power can be higher than input power, a transistor can amplify a signal. There are two types of transistor: bipolar and field effect. This slide shows the latest results achieved by leading electronic companies like Intel and Samsung. The world is developing and demand for electricity is constantly growing, which makes electronics grow faster and faster. Obviously, using the old technology, we cannot make a breakthrough. To reach a new level in electronics, it's necessary to radically change the approach to solving problems. Actually, to create new architecture, to research new materials, and to apply new principles, of course. Quantum technology opens up completely new possibilities for electronics. The computer on which you watch this webinar runs on the same basic technologies that are used in almost every computer in the world. This is a world of binary information. A bit can be either 0 or 1. Quantum computing, by contrast, uses qubits that can exist in virtually countless states at the same time. By the way, quantum computer could see all the billions of sequences simultaneously, which would significantly reduce time and costs. In fact, quantum computers will be able to make calculation in seconds, which ordinary computers would take thousands of years. Based on recent studies, one of the most likely candidates to replace silicon are carbon-based materials, carbon nanotubes and graphene, which probably could become the basis of future nanoelectronics. These materials demonstrate many unexpected electrical, magnetic, and optical properties, which have already become the object of a number of researches. For example, a feature of carbon nanotubes is their electrical conductivity, which is higher than that of all known conductors. Spintronics is a young and promising field of solid-state physics based on the existence of an electron spin. According to the plan of researchers, the development of spintronics will lead to the development of a new type of electronic devices in which charge transfer is responsible not only for electric field, but also for magnetic field. This method of current management seems more reliable at high temperatures. And the devices theoretically promise to be smaller, faster, and more efficient than their electrical counterparts. Unlike electronics, photonics doesn't work with electrons, but with photons quanta of light. For MIFI, such fields of photonics as microwave photonics is especially interesting, and we are working on the creation of the element component base of it. Microwave photonics researches the interaction of optical radiation and microwave radio frequency signal in task of receiving, transmitting, and processing information. Microwave photonics has found its application in areas such as transmission, with minimal loss of satellite communication signals, distribution of signals to remote antennas. On the territory of MIFI, there is a nanocenter. Nanocenter is a set of clean rooms in which a full cycle of manufacturing semiconductor devices occurs from growing semiconductor layers to testing the finished device. You can see our structure, the number of our departments, and our goal. Here are 3 undergraduate educational programs. You can choose the one that is of particular interest to you, depending on whether you want to be theorist or experimenter in various fields. At the program Nanoelectronics, Spintronics, and Photonics, you can study in English. Master's programs are presented here. I have to notice that we have English language, electronics, and nanoelectronics, Spintronics, and Photonics, and microwave photonics programs. Here is a list of postgraduate programs at our institute. The most popular options for the further work of our graduates is the position of a process engineer, structural engineer, or research associate, both in research centers in Russia and the world, and in factories of mass production of electronic components. Some of the graduates have the opportunity to engage in project management in high technology sectors. Thank you for your attention. I will be happy to answer all your questions regarding admission and study at MIFI on our programs. Thank you, Eve, and goodbye.